So homework for today was we were supposed to have the player successfully take an exit, allowing them to walk around the map. So I put a note on there, taking an exit means that the current room loses a player and a new room gains that player, and the player becomes aware of the new room they're in. So we have this coordination between the player and the room. Room knows about the player, player knows about the room they're in. A little bit creepy that we're having to think about rooms as kind of being self-aware. Kind of their eyes are on us, but that's kind of how we have to consider it in this particular situation. So let me open up that project. I think I log in with GitHub. Oh, excuse me. Is this the one I'm using? It should be 250, right? Yeah, I don't think I did, because I should see stuff related to my 450 class right now, and I don't. So do something else. We're just about ready to get into multi-threading. I'd be surprised if I logged in with, yeah. Right. Well, yeah, I logged in with my Google credentials this time. Yeah. Oh, well. All right. So let's see where we left off. I think from a player's perspective, we have our play function that we were writing, where when we first start playing the game, we show the current room they're in. Then we start doing some input from them. We ask the user, hey, what do you want to do? This is just in this infinite loop forever. We're going to keep asking, what do you want to do? What do you want to do? What do you want to do? We'll read it in. If they say look, we'll look around. If they say exit, we'll get out of this loop and finish. Otherwise, they must be picking a direction. So if they're picking a direction, we're going to first ask a question. Does the room we have, the room we're in, so remember, this is from the player's perspective. I'm asking the room, hey, do you have this exit? Again, the creepy talking to yourself in the room type situation. And the room is going to return. So if we go to the room here, they let us know whether or not they have an exit. So I'm going to give them a direction. That room is going to go through all of their exits. We are going to ask each exit, which is an object in and of itself, to get a direction string leading away from this room. Okay, because remember, the way our exits work, they're two-way streets. So I'm asking that particular exit if there's a direction leading out of here to that's equal to south, something like that. Okay. So this is going to boil down to whatever direction that particular exit is as a string leading away from me. And I'm going to check, is that equal to the direction that was passed in here? If it is, I'm going to return true. Yes, this room has an exit in this direction. Okay, this is just us being able to ask a question about that. Otherwise, if I've checked every single exit and I didn't find any of them in the direction I tried to put in, I'll return false. So back into the player. If this room has the exit, we need to then take that exit. So taking an exit will involve first of all, having the current player take the exit in a certain direction. So we started writing take exit here. So we give it a direction. It's going to go through all the exits. Presumably, we're going to get into this if statement, right? And we could have written this differently. We could have maybe had has exit return the actual room that it leads to, as opposed to a true or false. But I'm kind of keeping it, fairly straightforward in terms of the question. We're just solving small pieces of this problem. Room, do you have the exit? Yes. Okay, I want to take that exit then. So we're going to spin through until we find the direction we want. So once we have that exit in that direction, I need to go ahead and get the room. This dot, the exits. Actually, why don't we go ahead and get I'm going to do this. I'm going to create an exit called temp. We're going to set temp equal to that guy. Then we're going to say if temp has a direction in that in that direction, or has an exit in that direction, then I'm going to use temp to take the exit. Why am I putting this in a variable? Because we're going to be using it more than once. All right. So I'm going to say I'm going to take an exit from a exits perspective. So we'll say public. We'll have it return void. We don't need to say whether it was successful or not. And we're going to say travel in direction. And we're going to have the direction be passed in here. And then we're also going to have a room. Well, there's lots of ways you could have maybe solved this, but I'm going to have this exit have an ability called travel in direction. So I'm going to talk to this exit and say, I want to travel to the south from this room. All right. So the exit is going to have to figure out the destination room to the south. All right. So remember our strings up here. If the direction is equal to direction leading to dest 1, then we want to work with destination 1. If it's equal to direction leading to dest 2, then I want to work with destination 2. So if direction dot equals direction leading to dest 1, if that is the and I want to say this dot, if that's the direction that we're trying to move, then we're going to say this dot destination 1, which is a room, and then we want to do something with that. Else, and if we want, we can go ahead and be explicit with this, even though right now we just have 2 options with an exit. An exit's either one direction or the other direction. We'll make this protected from the perspective of what if they try to travel in a direction that doesn't exist? We know with our current workflow that we're going to ask a room, do you have this direction first? And then if you do, then we're going to take the exit. We know that's what we're doing. But since we're solving this in segmented pieces, travel in a direction is only going to work if we give them a direction that actually exists. So else if, correct, but the has exit question, we are choosing to ask that question first and then do something else. I'm writing this code so that it doesn't necessarily rely on us having asked that question. We are going to. That's just the question we're asking. We might have plenty of circumstances where we might be interested if there's an exit in a certain direction. That doesn't mean we're going to take the exit. So we're just kind of writing this guy where he's kind of playing dumb. He doesn't know how you got here. He doesn't know that you had previously asked that question. So he's only going to take an exit if you gave him an appropriate direction. Because if I just put an else in here, if you, whatever direction you pass in, if it's not equal to desk 1, he's just going to have you go to desk 2, regardless of whether it was the correct direction or not. So if it's equal to desk 2, then we're going to do something with destination 2. Okay. So now this is the room that we are dealing with here. Now, I'm going to have this taken another parameter too. We'll have it taken, well, we'll just call it the player. What's the direction from the room? Who's traveling? The player. All right. So regardless of whether or not it's destination 1 or destination 2, we are going to set the player's new room equal to where they're going. Make sense? So a player, do we have a set room? We have a set room. So we'll say the player dot set room equal to this dot destination 1 in that case. Similarly, if we're on this side, we'll say this dot destination 2. All right, so we just let the player know where they're going to land. Then we need to remove the player from the room they're coming from. So go to room. We have a remove player. So we'll ask that room to remove the player from the room. Now I'm only going to put it in this else or if, the if or the else if, because we are not going to definitely get into one of the two as I'm writing it here. We're only going to get into this if or the else if they gave me a legal direction. Even though, as you said, the way we intend to use this is we won't be calling it unless we have a legal direction. So we'll go ahead and say from room dot, what was it called? Set room or set player? Remove player. Remove player. So we'll go ahead and remove the player from the room that they're coming from. We're going to do that in both of these places, as opposed to just doing it out here where it will always happen, even if we don't give it a legal direction. Because if you say, hey, I'm going to go to the northwest, which we don't have that in here, this would then always still remove the player from this room. So now you're just floating out there in limbo. So even though we are repeating some code here, we will only do it if we're heading in the right direction. So we're going to remove the player from the room. Then we want to put the player into the next room. Add player. All right, so player becomes aware of the room they're going. Player gets removed from this room. The room we're going to becomes aware of the player. You could have done those in different orders if you wanted to, but at the end of those 3 lines, we've accomplished the communication that has to happen between all the stuff here. All right, so this is a function called travel and direction. I'm just going to steal that here real quick. So now from a room's perspective, we're a player standing in this room. So we're first going to ask the room, hey, do you have an exit in a certain direction? If yes, then I want to actually take that exit. And how do we take that exit? We go through all of our exits. We find the exit in that certain direction. And we say temp dot travel in a direction. What direction? The direction we're trying to go. From what room? From this room. And who am I? This dot current player. That's the player that's leaving this room. So we're going to tell the exit that's the correct exit, that we want to travel in a direction. We'll go ahead and go in that direction from this room with this player. Then we'll go ahead and return. Remember, return makes a function immediately end. All right, so we've taught a room how to take an exit in a certain direction, which then goes and finds the right exit and then travels through that exit with all the correct information. See how we're having our various players working together here? Objects working together here. When we get into start using Unity, when we kind of convert this into a not a really high graphics game, but convert it into something visual, a game. Unity calls things scenes, almost like this is a play. Okay, so these are the various actors that are part of the scene. We have a room, we have a player, we have some exits. These are the various actors that are involved. And in this scene, the player is leaving the room through an exit. Okay, so that's kind of the connection that Unity will end up making for us. All right, so we've taught a room how to take an exit in a direction. So now we go back to player. If the current room has a certain exit, we'll go ahead and take that exit in that direction. Okay, then we'll hit the end of this else. It'll spin back up. Now, we probably want to go ahead after we take an exit. We probably want to go ahead and show the room we're now standing in. This dot look around. So the player's now gone through this exit. We're going to now look around. We should see the new room we're in. And then it's going to spin back around and ask us, hey, what do you want to do next? All right, so we have an exit to the north here. I'll type in north. So now we are in hall 1. I have an exit to the west, the south, the east. We'll go to the east, hall 2. We'll go to the east, hall 3. We'll go to the north. Now we're in this room. So we're in S118B. I see an exit to the south. If I try to go to the north, it's just going to show me still in this room. I type in the south. We're going to head out into the hallway here. All right, makes some sense. Now, you may have gone about this in a little bit different way, but at the end of the day, you told the player to change the room to the next room. you told the room they used to be in that the player's not here anymore, and you told the place that they're going that they now have a player. Those three things occurred regardless of how you ended up accomplishing this, right? Okay, questions about this? Mm-hmm. There you go. Does anybody know if you click my link from the homework assignment, will it show my new updated code or does it show a snapshot? Oh, interesting. Okay, well, that's kind of good. So this is what solution to homework number. What homework number was this? 8. Thank you. All right. Any questions about this before we keep trucking? All right. So hopefully what we're starting to feel now is something I would have said in 200 is that all hard programs are made up of a bunch of easy parts. This program's starting to get kind of big, right? We got lots of objects at play here. We got a bunch of code written. Just here in player, we have 70 lines of code. Exit has 65 lines of code. Room has almost 100, so on and so forth. We got 250, 260, 70 lines of code now in our program. This is starting to balloon a little bit, right? And it's probably going to keep getting worse and worse. But as we are kind of letting our program almost naturally grow, saying things out loud. So, I mean, one thing I want to continue to encourage you to do is always draw pictures, but also maybe even do kind of what I do here in class where I say it out loud. This is what I want to do. Now, how do I do that? Okay. And take little tiny baby steps. That's kind of why I said, ask the room, do you have the exit? If yes, then ask the room to take the exit. Breaking that down into 2 subparts, even though we probably could have just said, let's try to take the exit. And if we slam into a wall, we slam into a wall. Right. All right. But in real life, we would probably glance around the room, notice the exits, and only take exits that were things. Right. Okay. So the next thing we might want to do. So now we have a world, we have our map. We got a player in the map. He can run all over the place, right? Okay, so now we're, a little, mouse in a in a cage or something. Okay, well, now we want to have some other things in there with us. Okay, so maybe we want to have monsters. You can call them whatever you want. So we'll say we're going to have monsters in the mud. So what is a monster? So if we're thinking about this from a mud perspective, a video game, you might be in a room and a lot of them are kind of Dungeons and Dragons-y. You might have rats or something like that, or goblins, orcs, whatever it is. Okay, but in this particular case, this is the department. The bad guys might be, I don't know what well, you probably should have the faculty be like a boss fight, right? You take out Blade. We're definitely putting that in there. It's developed a limp. He actually go fight with the crutches. It's pretty funny. That's happening, by the way. His weapon is crutches. is what it is, and it's gonna be awesome. All right. So now we have to think about, okay, if we're students working through the department, what might the monsters be? You know, we probably don't have a whole lot of rats that are, you know, happening around the area, but maybe we decide that in this twisted world, you know, it's these inanimate objects that have become animated and are now, like, maybe there's a chair in the room, right? And the chair has a grudge. I mean, you've been sitting on it. You've just been abusing this thing. Okay, but we're going to have other things in the room. But let's just, in our example here, assume it's a chair. If you want to think about it like a rat or a goblin or whatever, it doesn't matter. We're going to have a monster in the room. Okay, so I walk into this room and it shows me, you know, the things that are going on. If I go back into this, you know, it shows me, you know, here's my room I'm in. And then it says also here. Right now, the only things that go into the also here category is the player that's in the room, right? So I'm always going to see myself there. But when I walk into this room right now, you know, all of you are also going to be here, right? And then, you know, we're going to have some chairs and stuff, but maybe we decide that the room is a little bit empty. In fact, you know what? Let's keep it, rather than confuse the thing. We're just going to decide that our department is, who's infesting our department? What kind of monsters? So our player is going to hunt students. Homework number 9. Kill a student. Oh, yeah. I guess that could work, because then we have the faculty protecting the students. Blade limps in. And once we add multi-threading to this, Blade's going to just wander the department on his crutches. He'll be moving in and out of rooms. That's right. All right, so fine. We'll say that we have the player. You know what? We're gonna say rats. We're gonna have rats. All right. Because presumably the players in here are going to be the students, right? Those are going to be our players. So we're rat infested at this point. Go ahead. A who? A GRU. GRU? What is that? It doesn't sound familiar to me. Most MUDs don't, or I'm just getting old. What is a GRU? Okay, so bad monster, but we can't describe it, I guess. Oh, I see. Well, we'll stick with a rat. Let's stick with a rat for right now. Okay, so we want to say what is a monster. So if we're going to have, so we say maybe an example, maybe a rat is our first monster. All right, so we have this idea of a rat. Now, if you were thinking about, again, kind of in that idea of how Unity starts thinking about how our games work, it kind of treats it as like a scene in a play. So right now, what we've written is we have rooms, we have exits, we have players. All right. What is a monster? What are the attributes of a monster in its simplest form? We're going to add some attributes later, because right now we don't support killing monsters. We just support the existence of monsters. Okay. So what are the attributes of a monster? A name. Okay. Their attributes. You can think of those as our fields. So we're going to have a name. What else does a monster have? Yeah. Maybe if we start getting to the point where we're going to kill them. Yeah, but if we're not going to have death matches with our monsters, they probably don't need hit points yet. Good. Okay, so a monster needs to be aware of the room that they're in as well, right? So current room. So if I put myself in the rat's shoes, assuming they wear shoes, I know about the room I'm in, right? Go ahead. Probably where we're going, and that would be covered by whatever their current room is, right? Because we're thinking about not their abilities yet. We're thinking about the attributes. What things does a rat know about? If I'm a rat, I know about my name and I know where I am. What else? Okay, possibly. But now if I'm a rat and you're a player, we both know about our current rooms, right? So we both can ask this room who else is here. So maybe I notice him, he notices me, but by way of the room. We're looking around in this room to notice the other person, okay? So let's say as a starting point here, a monster is just this, a name and a current room. Okay. How does the monster differ from a player? Let's go back here for a second. I'm going to bring up player here. We'll scroll up. What are the attributes of a player? Name and a current room. So really, a monster and a player, from an attribute perspective right now, are the same. So what differentiates our player from a monster? Because they are different, right? Go ahead. Okay. Players controlled by user input. So we are moving that chess piece around, right? Okay, we are telling the player what to do. Where presumably the monster is controlled by the system, right? The AI of the thing. So who controls it is different. Okay, so we can maybe say at the simplest case, that is the differentiating factor. So we can't just make a player a monster, right? Because at that point, if we just say monsters are just another player, and we expand our definition of room to hold a collection of players, at that point in time, we now would have rats that presumably could be controlled by human beings, which maybe we might have a game where we allow for that, right? But typically games might have various player types, but you would still have a monster type, something that's always controlled by the computer, okay? So we really need to talk about inheritance. We're going to say a player is controlled by the human. A monster is controlled by the system. So what we're going to do is we're going to introduce a class called inhabitant. All right, if we draw a picture of this, we're going to have our inhabitant. And then from inhabitant, we're going to have a player. And we're going to have a monster. Now, we've already seen this kind of relationship before when we've been looking at the documentation, right? Where something is an object, but it's also an input stream, and it's also another kind of thing. So we've seen this kind of thing before. Okay, so we want players and monsters to also both be inhabitants. Make some sense? All right, so we're going to have to look at the inheritance model. Now, let me ask you this. Will we ever create a generic inhabitant? Or will our world only contain players and monsters, which are inhabitants, but we wouldn't walk into a room and just see this generic blob that is an inhabitant there, that's neither controlled by the computer or by a player because it hasn't gotten to that point yet, hasn't finished growing, right? So if we think about our scene in our movie, we would never actually create an inhabitant. Fair enough? Okay. Actually, just going to hijack this one. So we have something called inheritance. This is accomplished through the extends keyword. So we would have something like class inhabitant, and then we'd have class player extends inhabitant, class monster extends inhabitant. And we're going to say that an inhabitant has a name and a current room. So these are the attributes of an inhabitant. All right, but then we're going to say we're going to create another class called player that will extend inhabitant, and we're going to create a class called monster that will also extend inhabitant. Go ahead. We could decide. We could decide. Maybe we decide that inhabitants are only living. Otherwise, we have another kind of thing, maybe. But I don't think it would be unreasonable to say that anything that inhabits the room, dead or alive, whatever, is an inhabitant. I think that's a reasonable enough assumption. You know, if you don't want to get too detailed about the thing. All right, so what I can do in here, so we'll go back to our code. And I'm going to add a file here called inhabitant.java. This is going to be public class inhabitant. All right, and then this guy is going to have a, well, start it off as private string name and private room current room. I will just leave it at that for the moment for an inhabitant, since we're going to be up against the time. I just want to get past this step here. So we have name and we have current room. I go into player. Right now we see a player has a name and a current room. But we're going to say a player actually extends inhabitant. They are one of these. So a player is an inhabitant who is an object. Now, since a player extends inhabitant and a player doesn't have any unique attributes that an inhabitant doesn't already have, they might later, but right now they don't. I would remove those local variables. Now, if I try to run this right now, it's going to scream at me. Because even though a player extends inhabitant, it's going to say, hey, you're trying to set this dot name equal to something. You're trying to set this dot current room equal to something. Now, I'm telling you that since this guy extends inhabitant, it gets everything that's an inhabitant. But the problem is I've currently set these guys up as private. And what does private mean? Only accessible in that particular class. So private means, hey, if you're in the class inhabitant, you can access it. Am I currently in the class called inhabitant? I'm not. So what we can do is we can loosen the reins a little bit to something called protected. which will then expose these variables to the children of this class as well. All right. So now code still works, but I have changed the organizational aspects of my classes. We now have this really boring class called inhabitant that only brings to the table 2 fields. And then I have this class called player that extends inhabitant, so it's going to get those 2 fields from its parent. So when if this player says this.name, he's talking about his own name variable, which we don't see up here, but he received because he extended his parent. Go ahead. Well, it could be private as long as we're only going to use it inside of inhabitant.
But if we're extending it, like you say, how the player extends inhabitant, so does that mean this is protected is only going to the player?
Correct. Protected or public.
Okay,
so if I say private int count or something like that here, count would not be exposed to any other class. It would only be accessible inside of inhabitant because I made it private.
And then protected is only between player and inhabitant.
In this case.
In public would be.
Yeah. Let's say yes, that's true. Protected is a little bit kind of weird, but I teach from the perspective that protected is solely involving inheritance. So what you said is accurate. Yep. All right. So where we're going to start next time, give me 1 second. I'm going to save this for now. We're going to call this guy parents constructor and abstract is what we're going to talk about next class. Questions, comments, concerns, bribes, and I'll take your question because we're a minute over. So go ahead and start packing up, but I'll go ahead, ask your question. I'll keep the recording going. An inhabitant doesn't know about players. An inhabitant only knows about themselves and who they came from. They don't know about who uses them as a baseline. Yeah, so it's a one-way street. We can go up a hierarchy, we can't go down. Okay. And hopefully everybody saw it on Slack, but your next class is canceled. He broke not just his ankle, his leg.